So, good morning class. Today we will discuss about imperfections or defects in solid. We will discuss about the different types of imperfections or defects, and we will discuss them in detail and their different characteristic features. So, the topic is defects or imperfections, defects or imperfections in solids. So, a solid is said to be having defect or imperfection when the different particles are not at a fixed space or they show any randomness or disorder. And it is to be noted that a solid crystal only has complete ordered arrangement only at absolute 0, that is 0 Kelvin or minus 273 degrees Celsius. So, a solid can have the perfectly ordered arrangement of its particles only at absolute 0, and since absolute 0 is a hypothetical condition, it is a hypothetical term and it is not reachable. So, we can say that no solid in this world can have a perfect ordered arrangement, or we can say that each and every solid has some kind of defect or imperfection. So, there is no solid in this world which is having completely ordered arrangement, and each and every solid have some kind of defect or imperfection, and we have to discuss those different types of defects in detail. So, basically when we are discussing the defects in solids, so basically the defects are of two types. Basically the defects are of two types. It is metallic defect and the second one is electronic defect. Metallic defect and it is next one is electronic defect. Metallic defect is of further two types. It is of further two types depending upon whether it is point defect or whether it is lattice defect. Now, this point defect is further categorized into two terms or two further categories, that is stoichiometric defect and the other one is non-stoichiometric defect. Stoichiometric defect and the other one is non-stoichiometric defect. The stoichiometric defect is further categorized into four types. It is further categorized into four types, that is vacancy defect, interstitial defect, shocky defect and Frankel defect. These are the four characteristic features, whereas these non-stoichiometric defects are classified into further three categories. These further three categories are metal excess defect due to anion vacancies. The second one is metal excess defect due to interstitial cations, and the third one is metal deficiency defect due to cation vacancies. And these lattice defects are of further two types. These are line defect and plane defect. So, this is the entire categorization of defects or imperfections in solids. So, we have already seen that the imperfections or defects, we saw that a solid can have the perfect order arrangement only at absolute 0. Since absolute 0 is a hypothetical term, it is not reachable. So, we can't say that any of the solid has a complete arrangement and complete ordered arrangement of its particles, its constituent particles. Each and every solid of this world has some kind of defect, and we have drawn a flow chart of the different defects or imperfections that are found in solids. And it has also been observed that as the temperature increases, the defect or the imperfections in the solid also increases. So, and according to the increase in temperature, the more will be the increase in temperature, the more will be the defect or imperfection in the solid. So, mainly when we are discussing about defects or imperfections in solids, mainly they are of two types, metallic defect and electronic defect. Metallic defect are of further two types, point defect and lattice defect. Point defect are of further two types, stoichiometric defect, non-stoichiometric defect, and lattice defect are of further two types, line defect and plane defect. So, these stoichiometric defects are of further four types, vacancy defect, interstitial defect, Schottky defect and Frankel defect, and non-stoichiometric defects are of further three types, metal excess defect due to anion vacancies, metal excess defect due to interstitial cations, and metal deficiency defect due to cation vacancies. So, this is the entire flow chart for the different categories or types of imperfections or defects which are seen in solid crystals or solid lattices. So, we have to discuss each and every type in detail. Now, let us start from the first one. What do we mean by defects or imperfections in solids? So, what do we mean by imperfection? It means the change or disorder in the arrangement of particles which disturbs the properties of the solids, it is called defect or imperfection. So, any change or irregularity or disorder in the arrangement of particles, or it can be by any other cause also, which disturbs the properties of solids, shape and size of the solid, physical and chemical properties of solids, it is called imperfection or defect in solid. Now, we shall start the different discussing in detail of the different types of defects. So, let us start from the first one, that is metallic defect. So, what do we mean by metallic defect? So, this metallic defect means the defect or imperfection which arises by the constituent particles of the solid is called metallic defect or metallic imperfection. First one is atomic defect, is called atomic defect, is called atomic defect. So, the first type of defect is atomic defect. So, this atomic defect means that if the defect or imperfections arises due to the constituent particles of the solid, if there is a change in constituent particles or any disturbance in the constituent particles, and due to these there is a change in the shape or arrangement of the solid. So, this is called atomic imperfection or atomic defect. So, these are the two reasons. First one is the defect. What do we mean by defect or imperfection in solid? So, any change in the constituent particles or any change by any other source which completely disturbs the physical and chemical properties of solid is called defect or imperfection. And the first main type of defect is atomic defect. So, the defect which arises due to the constituent particles which are the constituent particles of that particular solid, and that type of defect is called atomic defect or atomic imperfection. Now, let us move forward. First one was atomic defect. Now, further in case of atomic defect, we have two further defects, that is point defect and lattice defect. Point defect and the other one is lattice defect. So, what is the meaning of point defect? When we are discussing about point defect, it means when the defect or imperfection, found in the solid is limited to a particular location and not spread in the entire solid, comma, it is called point defect. It is called point defect. Like if we take the example of a crystal, let this be a crystal and let these be the constituent particles which are found in these crystal. So, if the defect is found somewhere here or here or here or here or here, but if the defect is found to some definite position, some definite location, and it is not found in the entire lattice, in the entire solid, it is located only to a particular location, then this type of defect is called point defect. But what is lattice defect? When the defect or imperfection is found in the entire solid, crystal, and it is not limited to a particular space in the solid, comma, these type of defects are called lattice defect or lattice imperfections. Like if we take the example of a solid, let this be a solid and let these be the constituent particles which are found inside these solids. So, if the defect is found in the entire location everywhere inside the solid, if it is found in the entire solid, so this type of defect is called lattice defect or lattice imperfections. So, the further two classification of atomic defects were point defect and lattice defect. Point defect means if the defect or imperfection is not found in the entire solid, it is found to some particular locations or particular area within the solid, then these type of imperfections or defects are called point defects. Like if this be a solid crystal or solid lattice, and if these are the defects which are confined to a particular location and it is not found in the entire lattice, then this type of defect is called point defect or point imperfection. But if the defect is not located to some specific area or specific space inside the solid and it is widely spread in the entire solid, in the entire crystal, then this type of solid is called lattice defect or lattice imperfection. If let it be a solid crystal and let these be the constituent particles, and if the defect is found in the entire solid everywhere inside the entire solid, then it is called lattice imperfection. Now, the point defects are of further two types, that are stoichiometric defect and the next one is non-stoichiometric defect. Stoichiometric defect and non-stoichiometric defect. Stoichiometric defect and non-stoichiometric defect. Stoichiometry refers to the equal number of positive and negative ions. If there are equal number of positive and negative ions, then we say that it is stoichiometric, or the ratio between positive or negative ions is stoichiometric. But if there are not equal number of positive and negative ions, then we say that they are not in stoichiometry. So, stoichiometry and non-stoichiometry refers to the number of positive and negative ions which are found inside the crystal. So, when we are discussing about stoichiometric defect, so when the stoichiometry of the solid is not disturbed by the defect found in the solid, comma, it is called stoichiometric defect or stoichiometric imperfection. It is called stoichiometric defect or stoichiometric imperfection. But when we are discussing about non-stoichiometric defect, so when the stoichiometry of the solid gets disturbed by the defect or imperfection present in the solid, comma, it is called non-stoichiometric defect. It is called non-stoichiometric defect or non-stoichiometric imperfection, non-stoichiometric defect or non-stoichiometric imperfection. So, these are the further two types of point defects. So, point defects are of further two types, stoichiometric and non-stoichiometric. So, stoichiometric defects are those defects when the stoichiometry of the compound or the solid is not disturbed by the defect found in the solid, then such type of defects are called stoichiometric defects. But when the stoichiometry of the compound gets disturbed by the defect present in that solid, it is called non-stoichiometric defect. So, point defect are of further two types, stoichiometric and non-stoichiometric. Stoichiometry means the ratio between positive and negative ions. If the ratio is same, it is called stoichiometric, but if the ratio is not same, it is called non-stoichiometric. So, stoichiometric defects are those when the ratio between positive and negative ions, that is stoichiometry, when the stoichiometry of the crystal is not disturbed by the defect or imperfection, it is called stoichiometric defect. But if the stoichiometry of the crystal gets disturbed by the defect or imperfection, it is called non-stoichiometric defect. So, these are the two types of point defects. Now, let us discuss the two types of lattice defects. So, the lattice defects are of further two types, line defect and plane defect. Line defect and plane defect. Line defect and plane defect. So, when we are discussing about line defect, so if the defect found in the solid occurs along a particular line, comma, it is called line defect. It is called line defect. But if the defect in the solid, if the defect in the solid lies along a certain plane, comma, it is called plane defect. It is called plane defect, and this plane defect may be along any plane, that is x plane, y plane or z plane according to 3D Cartesian coordinate system. It can be along any plane, x plane, y plane or z plane. So, these are the different classification of further lattice defect, line defect and plane defect. Line defect means if the defect is lying along a certain line, then it is called line defect. But if it is found along a certain plane, that is along x plane or y plane or z plane, then it is called plane defect, and any case can be both of them. Now let us move on to the different types of stoichiometric defects. Let us discuss types of stoichiometric defects. Let us discuss types of stoichiometric defects. Types of stoichiometric defects. So, we have already seen that the stoichiometric defects are of further 4 types: vacancy defect, interstitial defect, Schottky defect and Frenkel defect. So, when we are discussing about different types of stoichiometric defects, we have to discuss 4 types, that is vacancy defect, interstitial defect, Schottky defect and Frankel defect. So, let us discuss all of them one by one. So, before this vacancy defect is equivalent to Schottky defect and interstitial defect is equivalent to Frankel defect. There is a slight difference, but more or less they are equivalent. Vacancy defect and interstitial defects are found in non-ionic solids, but Schottky defect and Frankel defect, they both are found in ionic solids. So, this is the overall explanation or categorization of stoichiometric defects. So, stoichiometric defects are of further 4 types: vacancy defect, interstitial defect, Schottky defect and Frankel defect. So, vacancy and interstitial defects are found in non-ionic solids and Schottky and Frankel defects are found in ionic solids. Vacancy defect is equivalent to Schottky defect and interstitial defect is equivalent to Frankel defect. So, we have to discuss them one by one. So, let us start from the first one, that is vacancy defect. Vacancy defect. So, what is vacancy defect? Let us see. So, vacancy defect means that if this be a solid and these are the constituent particles and one of the constituent particle is missing from its lattice site and one of the constituent particle is missing from its lattice site. So, this is the constituent particle missing. So, constituent particle is missing from its lattice site. So, let us see some of the features of this type of defect. So, first of this is that this defect arises when some of the lattice sites are unoccupied or vacant, that is the better word we can use. So, this defect arises when some of the lattice sites are vacant or empty. So, here it was supposed to have a constituent particle, but the constituent particle is missing from this, hence lead to the formation of vacancy defect. So, vacancy defect exists here. Second point about this type of defect is density of the crystal decreases because mass is decreasing, density of the solid decreases because volume is constant and density is equal to mass upon volume. So, since volume is constant, mass is getting reduced, so the density will decrease. And the third point is it is always found in non-ionic solids. It is always found in non-ionic solids. So, these are the categorizations of stoichiometric defect. So, stoichiometric defect are of 4 types: vacancy, interstitial, Schottky and Frankel. So, we have discussed the first defect, vacancy defect. So, vacancy defect arises when some of the lattice sites are unoccupied or vacant. So, here it was supposed to have a constituent particle and since the constituent particle is missing from this site, so a vacancy defect is created over here. Since the mass is getting reduced, the constituent particle is missing and the volume is constant. So, the density of the molecule or the crystal will decrease. So, due to this defect, density of the solid decreases and it is always